Hi and Assalamualaikum. My name is Norzari. My metric number is CE190166.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nursalwa Farahani Binti Mohammad, metric number CE190163.
Hi, my name is Hilal Nazri and my metric number is CE190217.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Syazwan bin Noordin. My metric number CE190243.
Hi, Assalamualaikum. My name is Adli bin Nasir, CE190156.
So we continue with introduction. So basically, digital signal processing is the use of digital processing, such as by computer or more specialized digital signal processor, to perform a wide variety of signal processing operation. The digital signals processed in this manner are a sequence of numbers that represent samples of a continuous variable in a domain such as time, space, or frequency. Next, through frequency domain, signals are converted from time or space domain to the frequency domains, usually through use of the Fourier transform. The Fourier transform converts the time or space information to a magnitude and phase component of each frequency, where phase is unimportant. Often the Fourier transform is converted to the power spectrum, which is the magnitude of each frequency component squared. The most common purpose for analysis of signals in the frequency domain is analysis of signal properties, where we can study the spectrum to determine which frequencies are present in the input signal. Frequencies domain analysis is also called spectrum. Next, digital filters. Digital filter also widely has been used in digital signal processing, where digital filters come in both which is IIR and FIR types. Whereas FIR filters are always stable, IIR filters have feedback loops that may become unstable and oscillate. The Z transform provides a tool for analyzing stability issue of digital IIR filters. It is analogous to the Laplace transform, which is used to design and analyze analog IIR filters. Digital filters is therefore rapidly replacing analog filters in many applications where they can be used effectively.
I'm gonna proceed to objectives of discrete Fourier transform. First, to define the discrete Fourier transform can be taken from frequency samples of discrete time Fourier transform. Second, to show how the discrete Fourier transform used to calculate a spectrum of any given infinite duration signal expressed as xn. The discrete Fourier transform DFT not only gives a spectrum representation of any finite length sequence, but it can also be used as a representation of periodic sequence formed by infinite repetition of one finite length period. This statement can be seen in a study by Steve Arrar, which he said that the DFT discrete Fourier transform can be enabled to compute the spectrum of an infinity duration signal xn. Third, to apply theoretical on simulation project using all the formula given in the class. We use Microsoft Excel and MATLAB to prove and obtain the correct answer and issue certain graph based on questions given in the instruction.
Hi, Assalamualaikum. My name is Hilal Affrie Nazri. My metric number is CE190217. Today I'm going to talk about my group's project's methodology. So, for the first point is we make a full research, which is Before we start this project, our group basically make a full research on the internet to make sure all our parts and activity doing great by the end of this project. The basic things that we do are understanding the basic concept of the time sampling and discrete signal as example. Next, about the flow of this project is it took us around 3 weeks to fully complete this project with the perfect criteria from the project instruction. The task has been divided into two groups, which is one group is collecting the data needed to execute the project, and the other one is working together to perfectly stimulate and the project using the required software. So, we know one of the objectives for a project is to define the DFT that can be taken from frequency sample of discrete time Fourier series. Next, we wanted to calculate a spectrum representative of any given length as example by using the discrete Fourier series. It is well known that all the simulation must be related with the theoretical so that we can prove and apply all those formulas that have been learned throughout the semester. All the statements above that I said just now is how we planning all our activities to make sure all tasks are doing smoothly from the beginning towards the end of this project. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Syazwan Noordin, and today I am going to cover about question part. Okay, for question number 1, we need to plot and determine its spectrum. Okay, firstly, we need to find our data. This is our data for group number 3. Next, what we need to do is we just put the data given to Excel like this, and then we can easily plot the graph by clicking this, and this is the graph for xn. Okay, for determine its spectrum, what we need to do is put the formula for real and imaginary. The formula that we need to use is this: magnitude equal to square root of Re power of 2 plus Im power of 2. Same as phase. Arctangent bracket of Im divided by Re. After using the formulas, what we got is like this: Re and Im. As I click on Re, this is the formula that we need to use. So after that, we can easily plot the magnitude and the phase, its spectrum. So this is the magnitude and phase for the signal xn. For addition, this is the manual calculation to find imaginary and real. After that, we can use magnitude and phase formula. Okay, for question number 2, we need to calculate the output signal of the filter system. This is the filter system given, has Z equal to 0.0068 and so on. Okay, firstly, what we need to do is we need to convert Hz to Hn. How we are going to do this? By using inverse Z transform. We can also use other method, which is Xn. We need to convert to Xz first, but it's easier for us to do as Hz is already given here. Okay. After we convert it to Hn using Z inverse transform, what we get is this 0.0068 without the Z. So what we need to do next is Yn equal to Hn convolution Xn. The process of convolution is a little bit too long because we decided to use sum by column method as taught in the class. And firstly, what we need to do is Xn. This is our graph. This is our data, Xn. And Hn. Hn is given. And we already convert to discrete time using Z inverse transform. So we can do a convolution method like this: 0.068 multiplied by 104.9, 0.068 multiply 55.24. This is what this is the answer for the yn. We need to solve yn equal to hn convolution xn by using convolution method. However, there are several convolution methods that have been taught to us in class. We decided to use sum by column method using Microsoft Excel. After we got the yn data, this one, we need to do as same as before, which is using the formula to get the real and imaginary. By using the formula, we can get real and imaginary, and if we are using real and imaginary, we can get magnitude and phase. Okay, for yn, we need to plot it first, and it will be like this, the signal of yn. Using the formula that I just showed just now, we can get the magnitude phase. So we will use the same method, magnitude phase and phase. This is our spectrum. Okay, for question number 3, we need to determine its spectrum, magnitude and phase. Okay, after using the formula, this is our magnitude and phase for the signal given yn. Signal after filter. Okay, to double confirm our answer, we decided to use different type of simulation, which is MATLAB. Okay, firstly we need to run it after putting a coding and some sort, and this is our yn, and this is our magnitude and phase. This is our spectrum. So the point here is 1369, and this will be same. That's all from me. Thank you.
Okay, for conclusion, from this project activity, we can conclude that we can observe and learn more about the DFT, which is can be taken from frequency samples of discrete time Fourier series. We also able to show on how the discrete Fourier series used to calculate the spectrum representative of any length. We also know and learn on how to use the simulation software such as Microsoft Excel to generate the signal from the given data. Last but not least, we can figure out on how to apply and relate our theoretical from we learn in classes onto simulation Microsoft Excel. That's all from me. Thank you.